In this video, we're going to go over a few examples involving some more complex hydrocarbons, ones with multiple branches, and also with some cyclic hydrocarbons. We didn't include that in our original video on hydrocarbons. So first we'll take a look at molecules that have multiple branches. So like this one here. So you can see that there's a branch here, one here, and then one here. If you take a look, the longest chain is this way, so it runs consistently. So we'll count that first. So we've got 1, 2, 3, 4, 5, 6, 7. So it's going to be heptane. And then we can see that on branch number 2, there are 2 methyls. And then on our carbon number 4, there's an ethyl branch. Now there is a rule that you would name them with in alphabetical order. So technically it should be written 4-ethyl and then 2,2-dimethyl heptane. So that's the name of that first molecule. And then down here, you might see some examples where they have a number splitting the word up, so that can be a little confusing. So this one is 3-propyl-dec-2-ene. The 2 in the middle is just a different way of saying 3-propyl-2-decene. They just show you where the position of the double bond is. So for this one, we'll need to draw out the skeleton chain. So I'll do the 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on carbon number 2 is the double bond. And then on carbon number 3, there's a propyl. So 1, 2, 3. You can draw it whichever way you wish. I'm going to do it like that so I can make it fit. And now we just fill in the carbon. So CH3, CH, and that one has the branch. So CH2, 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 and CH3. So that would be 3-propyl-dec-2-ene, sorry. So one thing that we didn't have in the original lesson on hydrocarbons was the concept of cyclic hydrocarbons. So these are pretty straightforward. What you do is you take a look at the number of points that there is in the shape, and that represents the carbon. You can also draw them out more with each carbon represented, but this is a common representation. So here there are 4 corners. So this would be cyclobutane. The next one would be cyclopropane, because there's 3. And the last one would be cyclopentane, because there's 5. So now we'll take a look at this one at the bottom. It's a little bit more complex. You can see it's a larger molecule, so there's more carbons. There's also a double bond represented and a functional group, a methyl group pointing off of it. So the first thing you would do is you would name the positions of the double bond, and you would start numbering the carbons there. If there were no double bonds, and you would name from the first functional group that you come across, and that would be carbon 1. So right here, this would be carbon 1. This is 2, 3, 4, 5, 6, 7, 8. So this would be, and it's an alkene because of the double bond, so it would be cyclo-oct-1-ene. And the methyl group is pointing off of carbon 4, so it would be 4-methyl cyclo-oct-1-ene.